Hello everyone, this is Shivani from my of Punjab. Today I will tell you the story of electrical contact to gallium oxide. As we all know that today there is a huge imbalance between incoming and outgoing solar energy, which is a major cause of global warming, and this global warming is governed by emission of various greenhouse gases by human activities. According to IPCC 2020 data, these are the top 10 countries which are major producer of the greenhouse gases. The greenhouse gases contribution coming from transportation, electric power, industry, agriculture. So the viable solution to reduce these greenhouse gases emission is by using efficient consumer electronic devices, by using hybrid electric vehicles, and by adoption of renewable energy. So for all this application, the major portion of this application is the power electronic circuit, which consists of rectifiers and converters. These rectifier and converters consist of a special arrangement of diodes, FET and BJTs in switching mode. So let us consider a simplified diode circuit. These are the output characteristic of a circuit in which I have compared practical one with the ideal one. Practically, diode offer a finite ohm resistance and finite pregnant voltage. Also, some leakage current is offered by a diode. Breakdown process is governed by avalanche breakdown, in which the breakdown field depends on the band gap of semiconductor. It increases with increase in the band gap. Also, the ohm resistance offered in forward bias by a diode is a material dependent. As you can see from this figure, that in comparison to silicon carbide, gallium oxide based device offer 86% lesser ohm resistance. By combining both these properties, we can fabricate a gallium oxide device with minimum power losses and high power rating. So these properties excite us to more study about the gallium oxide. So these are the intrinsic property of gallium oxide, which are quite good in comparison to other semiconductors. Also, there is a low cost of fabrication of gallium oxide along with high performance in comparison to other semiconductors. So to fabricate a device, we face multifacial challenges to fabricate a material which is defect free, also to passivate the surface and interface defects, because both these directly affect the device properties. In my thesis work, I will study the metal gallium oxide interface for ohmic contact fabrication, for which I have fabricated moly aluminum AU multi-layer transmission line pattern on gallium oxide thin films and anneal sample at various temperature and characterize them by using XPS, UPS depth profile and fabricate the band alignment, which comes out to be ohmic type. Thank you.